Hey everyone, sorry, I don't know what is happening today in terms of the videos, so I'm just going to go ahead and make another one here and repost it into YouTube, and hopefully you'll be able to access this one. So first of all, if you take a look in the top left hand corner, this is what we kind of talked about first period today as well. You want to make sure to really prepare for this class. You should organize your notes, right? And possibly even rewrite them. This is stuff that I learned in that course in college I was telling you about. So as you can see in my notability, I have these different subjects that break down like where I have everything, and as you can see, I have the notes for today. Now I've rewritten up here the notes because it should be 822, and I think in your file it shows 831. So just so that we're on the same page. But number one, for success, organize your notes. Number two, rewrite your notes. If you have sloppy handwriting or you're just trying to follow along, great, do that. But then when you get home, you really should try to rewrite your notes to make sure that they look a little nicer and they're easier to go back and look at before the test. Number three, always make corrections to your exit tickets, to your tests, your quizzes, whatever it may be. This is a big one that they told us in that course that is most likely to lead to success is correcting mistakes. Right? Making sure that you're learning from the mistakes and using them as a resource and not just a demeanor. So make sure always try to make corrections and ask questions if you need them. And lastly, when you're preparing for a test, don't just cram. Don't just study the test the day of. So if the test is Tuesday, which we do have our test Tuesday, okay, you always want to kind of split it up a little bit, right? If you cram 6 hours of content into one day, your brain is not going to be able to put any of that into long-term memory. So really have to space it out a little bit. So that way, this 2 hours, by the time you get to this day, it's in long-term memory, and then this 2 hours is in long-term memory, and now this hour, so it leads up to it. So that's a better success plan than just cramming that 6 hours. All right, so having said that, let's take a look at today's notes. Number one, or most of today's notes are going to be about theorems, as you can see. So it's all about properties of circles and chords, and hopefully this makes sense. So first theorem we're going to learn about is theorem 3. It says in the same circle or in a congruent circle, two minor arcs are congruent if and only if their corresponding chords are congruent. So what does that mean? Well, it says that arc AB is congruent to arc CD. Okay, so this arc is congruent to this arc. If and only if line AB or chord AB is congruent to chord CD. So it's basically saying the outside arcs are congruent, oh my goodness, if and only if these are congruent. And they are, because you can see it gives these little stripes right here. Okay, so let's look at an example. Example 3, in a diagram, circle A is congruent to circle D. Chord BC is equal to EF. So this is equal to this, which makes sense because, again, they got these little lines to prove that. And then it says the measure of arc EF is 125 degrees. Find the measure of arc BC. So it wants to know what's that measure. Okay, well, again, if their chords are congruent, then so are their arcs. So chord, congruent, arc attaches to that chord, arc attaches to that chord. So the measure of arc EF in this case is the exact same. It's 125 degrees. Pretty simple. Theorem 4 states that if QS is a perpendicular bisector, okay, so if it's, again, perpendicular and it creates a 90-degree angle, and bisector means it cuts in half, so if QS is a perpendicular bisector of TR, then QS is a diameter. So what it's saying is if it bisects this, if it cuts it in half, and it makes a 90-degree angle, then we automatically know that this is a diameter. Because if you're just looking at this, we don't know that it is a diameter initially. It doesn't show where the center of the circle is. It could be there, it could be there, it could be there. We don't know. But we do know now, since we know it cuts that one in half and it makes 90 degrees. Okay? Because otherwise, it could have been like this. Still cut it in half, but been kind of a weird line. All right. Theorem 5 then is kind of the opposite of that. It says if we know this is a diameter, so now see how it goes to the center, and we know it's perpendicular, then the diameter must bisect the chord. So if we don't know if this part is equal to this part, we automatically know if we know it's a diameter and it's perpendicular, and that means that these are congruent. Okay, so if EG is a diameter and EG is perpendicular to DF, then FH is congruent to HD. All right, so let's look at an example here. Find the length of BD. So it wants to know, what's this total length? Okay, well, since this is a diameter, you can tell because it goes to the center, and it's perpendicular, that means this is congruent to this, so this is 6 as well, so the entire distance is 6 plus 6, which is 12. So BD is 12. Okay, theorem 6. In the same circle or in congruent circles, two chords are congruent if and only if they're equidistant from and only the center. All right, so what that means is this is congruent to this, these two chords, if and only if these two are congruent. Okay, so if and only if AB and CD are congruent, if and only if FE and EG are equal. All right, so in example 6, in the diagram to the right, AB equals CD, which equals 12. Cool, so these are equal. Okay, find E of F. Everyone wants to know what that is. Well, since these chords are congruent, we know these are, so we can set them equal to each other. 3x equals 7x minus 8. I'm going to subtract 7x from both sides. Gives me negative 4x equals negative 8. Divide by negative 4. X equals 2. Okay, but that's not the answer because it says find EF. So now we have to take that 2 and plug it back in. So 3x was 2, so we plug that in and gives us 6. EF equals 6. Okay, let's go through some practice now before you start your exit ticket. Number 1, if the measure of arc TV, this arc, is 121 degrees, find the measure of RS, which is this, arc RS. All right, so right away we're looking at this, and we notice that we have two chords in the same circle that are congruent. That means their arcs are congruent, which means that the measure of RS is 121 degrees also. Okay, next one, find the measure of CB, BE, and CE. All right, CB, BE, and CE. So we need to find the individual, and then the whole thing. Okay, well, if this were a central angle, since it's 90 degrees, we'd be like, oh, this is equal to 90 because it's a central angle. But it's not, okay? It connects over here, and this is clearly the center, right? So it's not a central angle, so it's not equal to 80. So instead, we're going to look at it and say, okay, well, if this is a diameter, and this is perpendicular, that makes this equal to this, which means that this has to be equal to this. Okay, so we're going to set them up. 4x equals 80 minus x. I'm going to add x to both sides. 5x equals 80. Divide by 5. X equals 16. Okay, but again, that's not the answer. That's just what x is. So now we got to plug it back in. So 80 minus 16 gives us 64 degrees. 4 times 16 gives us 64 degrees. Okay, so arc CB is 64 degrees. Arc BE is also 64 degrees. So that means arc CE, which is both of them combined, this is the theorem we talked about yesterday, is 128 degrees. Done. Okay, in the diagram from example 6, suppose AB equals 27, E and F are both the same, and they equal 7, find C and D. Okay, so what we need to do is copy this down. So I'm going to erase this stuff off real quick. Oops, I don't want to copy that. We're going to take this picture, we're going to paste it down here. Move it down a little bit. I'm going to change it to a white so I can get rid of these numbers. Okay. All right, and it says AB equals 27. EF equals GF, so EF is 7, GF is 7, and it wants to know what is CD. What is this? Okay, well, since these connect to both the chords and they go to the center and they're congruent, that means these also must be congruent. So CD is 27. Done. All right, so finish up the exit ticket. Hopefully this video posts, and let me know if you have any questions.